Aloha, Richard Halverson here. This is ITS148, and we are in the fast sort algorithms chapter. And today, in this video, I'm going to show you how to do our number 17.5, which is sorting user IDs using Quicksort. So let me share my screen. Okay, so we're in chapter 17, and if you look at this it's quicksort algorithm. So first, let's take a look at the problem we're doing. And we see that we got some names here, and we're supposed to sort them. Supposed to say, what are we supposed to say? How many times quicksort is called? The quicksort algorithm, the program, the method is called, and that's what the 7 is. And then it outputs the list sorted. It reads in the list like this, and then the terminator is -1. Sentinel. All right. So here's what we're supposed to do. We're supposed to finish this program here. Let me just kind of make it bigger here. And this is actually a very easy problem. Okay, I'll show you how easy it is. And you know, in the old days, basically we were finding the algorithms we need someplace, and then we are putting them in there, and then making sure all of the calling, the way it's called, is correct, the signature, you know, the order of the parameters, and then also the names of the variables. Just you have to match those up. And this that's usually what it's what a lot of programming is today. So that's what this problem is. Okay, so what we have to do is we have to find a partition algorithm and put it there. And this is the quicksort, and the way this is going to work is we define a list, we read in the list, how does this work? Do I need to do anything? It's loops. It loops. Oh yeah, right. There we go. So it reads in the names one at a time. It doesn't read in a list and a split. It reads in the names one line at a time, and then it calls the quicksort algorithm and on the array user IDs, and then you know how quicksort works, and we're going to review that very shortly. It's got the list. It partitions it into with the middle element, the pivot element, and then it starts swapping, making sure that all of the elements on the left are smaller than all the elements on the right. Okay. Now those two partitions are not necessarily sorted, but then it's recursive. It calls itself again, but on a different you know, range, and it does all the ranges, and when it's all done, it's this array sorted. And then and what we're supposed to do is we're supposed to count the number of calls. So in quicksort, we're just going to have we're going to increment this variable. We're going to increment that variable inside quicksort. All right, and then it prints out here. Okay, so now let's go back and look at. I'm going to go. See, I think I can just, let me just go back here. And if we look in chapter 17, this is the quicksort algorithm right here. And this explains quicksort and partitioning. This more or less explains what I just said in a much better way. And it gives the algorithms here. And this tests your understanding of quicksort. Go through that. This does it. It's another thing, the pivot elements, and so on. It discusses runtime. It's a very fast algorithm, but still O(n squared worst case. And then this is the algorithm here. Here, this is the partition, and this is the quicksort part. And then this is some code that uses those two methods. Okay, so this is, I'm going to put this, actually, I cheated. Okay, so I have that over here. This is section 17.1. Let me go back to let's go back to the problem we're doing, and let's do this problem. Okay, so first we're gonna I guess I should make this so I can get at here we go. I want to get at this. Make it big. Okay. All right, first we write the partitioning algorithm, and it goes right here. So this is the array, and this is the lower partition, the lowest and the upper. That's the partition of numbers that it's gonna sort. It's gonna do the pivot thing, and so that goes here. Now, what does this one look like? What is this partition? Let's find it. Here we go. This is partition. Looks like the array is called numbers, and it's not. Array is not called user ID. It's called numbers. But other than that, it doesn't matter. That's right. It can be called user IDs out here. Oh, we're doing partition. It can be called user IDs out here and numbers inside here. Not a problem. We don't even have to worry about that. So I'll tell you what I'm going to do. I'm just going to copy this. Copy. And I'm just going to paste that bad boy. Just go back here. So, and I'm going to do, I think I can just do right click paste. I think it's going to paste in plain text. Okay. Now those indentations aren't quite the same, but they are. Okay. Okay, so here's our partition. And we can see that it does the midpoint thing, figuring out what the partition is, kind of like a binary search, isn't it? And goes through and does the swapping thing. It's dit swap, and then when the low and the high cross, then we're done. It's and here's the swapping. Anyway, looks good. I think that's all we have to do. So let's go now to, oh, wait a second. No, we got to do one other thing. We need to either change this. Here it's called user IDs, and here it's called numbers. Since it's called numbers all the way through here, I'm going to change this one to numbers. Okay, so even though it's called, we're doing partition here. Its partition is called, oh, this is confusing because I should have copied in Quicksort first. Let's just copy in Quicksort now. It's called numbers, user IDs, IK. Oh, it's even called IK. So I'm going to copy this. I could actually just copy the whole. I should copy the whole this from here, but I won't. I'll copy from here to here. Copy. And I'm going to paste that right here. And so here it's called user IDs. Inside here it's called numbers. Okay, so let's call this numbers. And then down here, when it calls partition, here's where it calls partition, which is what we just pasted up here. Coincidentally, it's named the same. It doesn't matter. We can rename it here. The original call of Quicksort, out here we call it user IDs, but then as soon as it's called, inside here it's that array is referred to as numbers. Yeah. And then it's partitioned and sorted and everything. And we are passing a list, and a list is mutable, which means when you pass the list to a method, and the method can mess with it. And when it returns, you get back the messed with array. Okay. That's not true with other types of variables, call by value, call by reference, and all that. But anyway, so this is fine because we actually do want to modify this array. We actually do want to sort that array itself and not just make a copy of it. Anyway, so this here, this may, okay, let's see what this gives us. I'm going to copy this data right here, copy, and I'm going to paste it down here, this is code that's going to be executed. And let me make this bigger so we can see it. So this is my input code. This is my program. I'm going to run and see what happens. Oh, look. It works, except for the counter thing, this count thing. So we need to put the counter in Quicksort. We just need to count how many times Quicksort is called. Okay, so first of all, we're gonna say what, since we're using a global variable. This one is a global, but this is what we're going to increment there. So that's what we're going to increment. And so inside Quicksort, we have to increment that. It's called num calls. So I think all we have to do is go, first we have to say global num calls. And then I think we just have to increment it, because every time this is called, it's incremented. So I'm just going to do num calls incremented by 1. And let me run it now. Run. Oh, look, I got the same answer as they did. So I guess that's it. You can submit it for real and see if you get all the points. Thanks for watching.